Let's get started on Chapter 7, Creating and Configuring Virtual Machines. In this chapter, we will look at a virtualization overview, installing Hyper-V, using Hyper-V Manager, creating a virtual machine, installing a guest operating system, installing guest integration services, adding RAM, dynamic memory, smart paging, and resource monitoring. Let's start out with a virtualization overview, and let's discuss what is virtualization and why would we use virtualization. So let's do a review of the physical architecture. In other words, before we talk about virtualization, let's talk about non-virtualization using traditional servers. Let's look at the traditional server-based network whereby we have multiple separate servers. Here's the example. The user stands at the workstation, and the workstation connects to a switch, and the switch connects to another switch which is located in the server room. And in the server room there are multiple servers, a file server, an application server, and a domain controller. Notice each server is installed on a separate physical machine. This is the typical traditional way of setting up a server room. The problem with server-based networks is that there is an inefficient utilization of resources. Here's the example. When we first set up our data center here at the Community College of Baltimore County a long time ago, we got 4 servers, and each one had 4 CPU and 8 gig of RAM, and at the time that was a lot. And we planned to make our first server a DNS server, and the next one was going to be a DHCP server, the third one was going to be a file server, and the fourth one was going to be the student registration server. But after we got all the software installed, and after we got them all up and running, we found that the DNS server and the DHCP server were only running at 25% of utilization. In other words, we assigned 4 CPUs to this server, but it really only needed 1. That's a waste of 3 CPUs. Some of the servers were operating at only 25% capacity, but other servers were totally maxed out. The file server, and most importantly, the registration server, were running at 100% of utilization. Now, I wish I could just take my fingernails and pull the CPUs out of these machines and move them over to these machines, but it's just not that easy to move the CPUs around. In the traditional method, the problem with the traditional method of having separate physical servers is that there is an inefficient allocation of resources. And the solution is to implement server virtualization. In server virtualization, we install multiple server operating systems on one big computer. Let's look at the IBM Blade server. An IBM Blade server is a big old server as tall as I am, and it has multiple blades. And you see this thing here that the guy is pulling out? It looks like a lunch tray. Well, that is a blade. And if we look closely at one of the blades, we can see that a blade is a circuit board which has 2 microprocessors and 4 gig of RAM. And a blade is kind of like a motherboard, and you know what a motherboard is. A motherboard is a circuit board which has a microprocessor on it and RAM. Each blade is kind of like a motherboard in that it's a circuit board with 2 microprocessors and 4 gig of RAM. So if our blade server has 32 blades in it, that means it has 64 processors and 128 gig of RAM. To implement server virtualization, what we do is we install the multiple server operating systems on the big old Blade server. And each one of those server operating systems is called a virtual machine. We install multiple server operating systems on the Blade server. The Hypervisor. A Hypervisor is a piece of software that allows the Blade server to host multiple operating systems. And Microsoft's hypervisor is called HyperV. When we say that a computer is a Hyper-V host, we mean it's a big old computer that has Microsoft Hyper-V installed on it. A Hyper-V host is a big old server that has Microsoft Hyper-V installed on it. Multiple virtual machines run on the Hyper-V host. On this one big computer, I can have a Windows 2012 server, a Windows 2008 server, a Windows 2003 server. I can even have a Linux server. Let's view the contents of the Hyper-V host and look at each one of those virtual machines. If we look at the Hyper-V manager, we can see on this one computer there are multiple virtual machines running. Each virtual machine is a separate operating system, and you can see each one is taking a different amount of CPU utilization and a different amount of RAM. Since different servers have different requirements, we can allocate a different amount of RAM and a different number of CPUs to each virtual machine. For example, we might just allocate one CPU and 2 gig of RAM to the DHCP server, 2 CPUs and 4 gig of RAM to the DNS server, 6 CPUs and 8 gig of RAM to the file server, and we could allocate 7 CPUs and 10 gig of RAM to the registration server. Can you do that? Can you allocate 7 CPUs to one single virtual machine? Absolutely. That's the whole advantage of virtualization. Notice, we have the same number of CPUs. We have a total of 8 CPUs. But instead of assigning 4 CPUs to each operating system, we assign 1 CPU to the DHCP server, and we assign 7 CPUs to the virtual machine, which is going to function as the registration server. With server virtualization, we have many servers which are called virtual machines, which are running on the same host computer. And each virtual machine is assigned a different number of CPUs, a different amount of RAM, and an amount of disk space. And the whole purpose is efficient resource allocation. Let's do a comparison between the traditional network infrastructure and a virtualized network infrastructure. In a traditional network infrastructure, some of the computers are only operating at 25% capacity and others are totally maxed out. The disadvantage is an inefficient allocation of resources. But if we look at a virtual network infrastructure, we see that we can have multiple virtual machines running on the Hyper-V host, and different virtual machines are assigned different amounts of RAM and a different number of CPUs. Let's look at some of the additional advantages of virtualization, such as consolidation, elimination of server sprawl, reduced power consumption, and cabling consolidation. This is what our server room looked like a long time ago. And every time we would add a new server, we had to add a power cable, an Ethernet cable, a keyboard cable, a monitor cable, and a mouse cable, and that was just an absolute mess. But when we implement virtualization, well, that's just another word for consolidation. Instead of having 5 physical servers, as we have here, we would have the 5 operating systems installed, consolidated on this one big Hyper-V host. This eliminates server sprawl. It results in a reduced power consumption. It performs cabling consolidation. So instead of having to have 5 different power cables, I just have 1 power cable to the Hyper-V host. And also it's easier to upgrade. It's easier to upgrade by adding an additional blades. And as you know, a blade is a circuit board with 2 CPUs and 4 gig of RAM. You can just add an additional blade and that upgrades the entire server. When we first bought our blade server here at CCBC, we bought the rack and we just bought 4 blades. And as time grew, we bought more and more and more blades until our first blade server is totally full, and now we are working on a second blade server. In server virtualization, we have multiple server operating systems, which are called virtual machines running on the same host. Each virtual machine is assigned a different number of CPUs, a different amount of RAM, and a different amount of disk space, and the advantage is a more efficient allocation of resources. And this concludes our general overview as what is virtualization and why do we use it. Let's now move on to installing Hyper-V on one of these big old blade servers. To install Hyper-V, we go to Server Manager and we select Add Roles. We go down to Server Manager, and under Manage we select Add Roles and Features. Under the Add Roles and Features wizard, we click Next, and we select Role-Based Installation, followed by Next. We select the server onto which we want to install Hyper-V, followed by Next. Then we select the Hyper-V role. If I click on Next, I see a prompt that tells me these other features and programs are required for Hyper-V. Do you want to install them? And I say, of course. I then click on Next. I will not add any additional features right here, and click on Next again. Then I see a brief description that tells me that Hyper-V allows you to virtualize your server workloads by running those workloads on virtual machines. You can use virtual machines to consolidate multiple workloads on one physical server. I will then click on Next. Then I am taken to the screen, Create Virtual Switches. And it tells us that virtual machines require virtual switches to communicate with other computers. We will talk more about virtual switches in Chapter 8. So the question is, of the two Ethernet cards which are on this Hyper-V host, which one do I want the virtual machines to use? And I will select the first Ethernet card. Then I will click on Next. It says, do we want to configure for a virtual machine live migration? And if we look at the explanation across the bottom, it says, if this server will be part of a cluster, do not enable migration now. Instead, you will configure the server for live migration, including specific networks, when you create the cluster. So we will not click on the checkbox for live migration. Click on Next. We can then see that Hyper-V will be installed onto the C drive of our server, and if we did not have space on the C drive, we could save it on another disk. I will click on Next. I click off on the checkbox that says Restart the destination server automatically if required. Then I click on Install. And then it installs Hyper-V. After it installs Hyper-V, the server then reboots. I do not press any key to boot from the DVD. I then log in as the administrator, and when I go to Server Manager, I see that Hyper-V has successfully been installed. To create the virtual machines, I click on Tools, and I slide down and I select the Hyper-V Manager. And this takes us to the Hyper-V Manager. If we look at the description, we can see that a virtualization server is a physical computer that provides the resources to run virtual machines. And if we look on this server, we can see that there are currently no virtual machines. So let's create one. I will right-click and select New, followed by Virtual Machine. I look at the New Virtual Machine wizard, and it tells us that this wizard helps you create a virtual machine. I will click on Next, and then I am prompted to give the virtual machine a name. Since this machine is going to act as a file server, I will just give it the name File Server 1. Then I click on Next. Then it says, how much memory do you want to assign to this virtual machine? Well, in this case, the entire computer has 32 gig of RAM. So I will just assign 4 gig of RAM to this virtual machine. I can always assign more later if necessary. But in this case, I will just assign 4 gig because that's all I think I'm going to need. Dynamic memory we will discuss later. Click on Next. Then I select the virtual switch that I previously created, which is connected to our Ethernet card, followed by Next. Then it says create a virtual hard disk. A virtual hard disk is a single file which appears to the virtual machine as if it is a physical hard disk. The hard disk on this server has over a terabyte of hard disk space available, but I am only going to allocate 40 gig of that total hard disk space to this one virtual machine because I have many more virtual machines to create. I allocate 40 gig of hard disk space to this virtual machine. Click on Next. Then, do I want to install the operating system now or later? I am going to install the operating system from the DVD. So I will select the operating system that says Install from the DVD, which is the D drive. Then I click on Next. I click on Finish, and then it creates the new virtual machine. Now I can see that the new virtual machine has been created. File server 1 has been created. If I right-click on that machine and I select Connect, I am now looking at that virtual machine, and as you can see, it has not yet been turned on. Now, we have created the virtual machine, meaning we have allocated a certain amount of RAM, but we still have not installed the operating system. So if I click on the Start button, I can start the virtual machine. And then it tries to boot from the DVD drive. And if you look at this error message here, it tells us that the DVD is not in the DVD drive. Put in the DVD drive, and then reboot the machine. So I put the DVD in the DVD drive, and I select Restart. And then what it does is the virtual machine boots to the installation disk in the DVD drive. You can see that Windows Setup is starting, and this takes me to the Windows 2012 install screen. So now what I'm doing here is I am installing the operating system in the virtual machine. I select Next, I click on Install Now, I select the edition that I want to install, followed by Next. I accept the licensing agreement, I click on Next, and then I have an option to upgrade or do a custom install. I am going to do a clean install. There is no option for clean install. When you're doing a clean install, the option that you would select is custom install. So I select custom, and I select the 40 gig hard disk, virtual disk that I made earlier. I click on Next. And then what it does is it goes through the installation process. It copies the files from the DVD to the virtual hard disk, which is associated with this virtual machine. After all the files have copied, it reboots. Now, it's not rebooting the entire server. It's just rebooting the operating system within this virtual machine. And then I type in an initial administrator password, and I confirm the password, followed by OK. Then I log in, type the administrator's name, and now I am logged in to the operating system which is installed within the virtual machine. Now, as you know, when you install an operating system, one of the first things you do is you give it a name, because when you install the operating system, it's assigned a randomly generated name. So I will right-click, and I will assign a name to this computer, such as File Server 1. Now, wait a minute. Didn't we name it File Server 1 a little bit earlier? You got to name it twice. You name it first when you create the virtual machine, and then you name it again when you install the operating system within the virtual machine. The names do not have to be the same, but it's a good idea if they are. And then I specify the DNS suffix, which in our case is ccbcmd.edu. And what I will not do is assign it a static IP address. I could assign it a static IP address, but in this case, I will just leave it as a DHCP client. I click on OK, and it tells me that since you have renamed the computer, you've got to restart the virtual machine. Remember, I am just rebooting the operating system within the virtual machine. I click on Restart. It restarts the operating system within the virtual machine. And then I log in as the administrator, and now we can see we have successfully installed the operating system in the virtual machine, which is located on the Hyper-V host. We can see that the virtual machine is currently running on the Hyper-V host. When we create a virtual machine, there are really two steps. First, you create the virtual machine, meaning you specify the amount of RAM and the amount of hard disk space that's going to be allocated to that virtual machine. Then you install the guest operating system, such as Windows 2012 Server or Windows 2008 Server or Windows 2003 Server, whatever operating system you're going to install. And of course, typically after you install an operating system, you give the guest operating system a host name, a DNS suffix, and an IP address. In this case, I didn't assign it an IP address. I just left it as a DHCP client. Multiple virtual machines. Typically, you're going to have multiple virtual machines running on the Hyper-V host. On this one physical computer, you can see I have multiple virtual machines installed, and each one has an operating system installed in that virtual machine. Each virtual machine is using a different amount of CPU utilization and is using a different amount of RAM. Now let's look at installing guest integration services. Guest integration services is used to improve the operation of the host operating system. You typically install it on pre-2012 Release 2 servers. And the example would be on a Windows 2008 server. So what we do is we install the guest integration services after the operating system has been installed in the virtual machine. So if I go to the Hyper-V Manager, I can see I have a server here, which is Windows 2008 server. I don't know if you can see this little tiny thumbnail down here, but that's how I know it's Windows 2008 server. So I go to that server, and I right-click, or I go to that virtual machine, and I right-click, and I connect to it. And you can see it's running Windows 2008 server. So to install the guest integration services, I select Action, I select Guest Integration Services, and I select Install Hyper-V Integration Services. I click on that, and then what it does is it copies the Hyper-V Integration Services into that virtual machine. And then after Hyper-V Integration Services has been installed, I have to restart. I'm restarting just the virtual machine, not the entire computer. I click on Yes, it reboots Windows 2008 server, and then I can log on to that Windows 2008 server. If I go to that server, that virtual machine that I just installed, and I look at settings, we can see that there is the guest integration services which we have installed. And when you install guest integration services, it adds services that make the operating system run better. And these are the services which have been installed: operating system shutdown, time synchronization, data exchange, heartbeat, which is used for fault tolerance, and backup, meaning it supports snapshots. Guest integration services is used to allow the operating system and the virtual machine to run more smoothly. Now let's look at creating a virtual machine using a PowerShell. Previously, we have created virtual machines using the graphical user interface. I go to PowerShell, and in PowerShell, I type the command that says new VM, name, file server 10, memory startup 1 gig, new hard disk 40 gig. So what this command says is we're creating a new virtual machine, and the name of the virtual machine is file server 10, and the amount of memory being allocated to this virtual machine is 1 gig, and the hard disk size is going to be 40 gig. I press the Enter key, and then it asks me for the path of the virtual hard disk. This virtual hard disk will be installed on the C drive, and the name of the virtual hard disk will be the same name as the virtual machine. I will call it File Server 10. Notice it has an extension of VHDX, which is a virtual hard disk format. I press the Enter key, and we can see that the virtual machine has been successfully created. So you can create a virtual machine using the graphical interface, or you can create a virtual machine using PowerShell. And this concludes part